What exactly are stormwater treatment tools and their multifunctionality? How does water-centred urban design achieve both resilience and livability outcomes?
One of the key fundamentals in managing a city as a catchment is to ensure that the stormwater runoff from our cities are cleansed before they are discharged into our receiving water bodies. Stormwater is unique in our catchments because they are generated everywhere in our cities. As rain falls and water runs off our catchment, it washes with it all the pollutants that are deposited in our urban environment. They are pollutants that are generated from vehicles, from human activities, from fertilizer use in our lawns and all that. And when it rains, all of that basically get moved into our receiving water. So stormwater treatment is very fundamental in ensuring that stormwater quality discharged to our receiving waters meets the water quality standard that prevents the degradation of our waterways. Let's look at stormwater treatment as a concept. Let's look at stormwater pollutants. There are many types of stormwater pollutants that are generated, and this slide gives an example of the types of categories of stormwater pollutants that we are concerned with, ranging from things that we see, the gross pollutants, the litter, the rubbish, to the sediment, to things that we don't see but we know are in the water. The nutrients, the chemicals, the metals that are in our stormwater. The sources of those pollutants are also highly varied, linked to the land use practice, as you can see on the slide here. This slide, in fact, talks about the way that a lot of our stormwater management practitioners categorize the physical character of stormwater pollutants. You will also see in this slide the management issues that we need to manage those pollutants for. And finally, to the right of this table, you'll see the type of treatment processes that we could apply to remove those pollutants. So if you look at the left column, that classifies the type of stormwater pollutants you get according to their size. At the very top, you'll find that we refer to gross solids, or if you like, in our term, gross pollutants. They are litter, they are debris from urban environment that gets washed into our receiving waterways. We see it all the time, from the soft drink cans to cigarette butts. They are solids that contaminates our waterway. If you look down that column, you'll find that we move from gross solids to what we call coarse to medium-sized particles. They are generally your sediment. You see them in terms of the sand and some of the rocks and soil that you see carried by stormwater every time it rains. And you get further down to what we will refer to as fine particulates and very fine or colloidal particulates. The only way that you often can see them is in the cloudiness of the water. Every time it rains, if you look at the water that runs off the road, you'll find that they are often very cloudy or highly turbid, as we call it. They are in fact carrying suspended fine particles that are constantly held in suspension through the movement of water. And finally, you have the dissolved particles, which you don't see, but we know are in there from the chemical processes. The management issues that often we have to deal with in managing these pollutants would range from visual, what you can see, the pollution that you see in the waterways, the floating rubbish that you see in the waterway, all the way to things that you don't see in terms of nutrients and metals. And so we manage pollutants to address those management issues or those objectives that we want to get to. And on the right column, you find that there are different treatment processes that we can introduce into stormwater treatment to try and remove those contaminants. Right at the very top of the chart, in terms of gross solids or rubbish or litter we see in our waterway, simple screening is actually a very effective way of removing them. So you'll find, in fact, throughout a lot of our cities that there are screens that tries and trap those gross solids and let the water through, and through that process remove that. As the particles get finer and finer from the gross solids, you find that the measure that we need to adopt to remove them will get more and more technically sophisticated. For instance, in the removal of coarse sediment, the sands, we would have to think about the process of sedimentation. And that is simply about holding the water in a pond or a tank and basically allow the heavier solids to settle out, so sedimentation. There is also the process of enhanced sedimentation, whereby we would use vegetation to also act as a filter to remove those fine particulates and at the same time allow gravity to let these solids settle. With the dissolved contaminants, the process we adopt is a biological process. It is about promoting uptake of those contaminants through biological processes, and that is where the treatment process gets even more complicated. This next slide is basically building from the slide that we presented previously that now show the treatment measures that we apply in our urban environment. And you can see again from the gross solid position, we use devices called the gross pollutant traps. They are traps to remove those gross solids. And then we have sediment basins, the ponds that you see in a lot of development, they operate to settle out the coarse sediments. We then look at grass swales. Sometimes you can see them in our development, and their aim there is basically to allow water to flow through the vegetation and through that process promote the process of what we refer to as enhanced sedimentation. We have sand filters and biofilters. The aim there is now to pass water that contains even finer pollutants, the colloid, the colloidals, and the dissolved, through a media whereby a combination of filtering to set through that media, whether it be sand or sandy loam, and at the same time promoting contact with organisms and microbes to enable biological uptake to occur, is where we try and remove those very fine to dissolve contaminants. And you can see through that chart that we go from filters to constructed wetlands to infiltrations. And as we go further and further from left to right in the chart, you find that the technology and the land take for those treatment measures will grow larger and larger. And this is reflected in the third column to the right, which talks about what we call the hydraulic loading, or how quickly can we run water through those systems. With gross pollutant trap, you can see the number is a large number. And that means that you can actually put through a lot of water quickly because we're simply removing the large stuff. If you look at the wetlands, you'll find that the number reduced significantly, which means that you now need to hold the water for much longer to enable the biological processes to take effect to remove the soluble contaminants. The delivery of those technologies are now throughout a lot of our urban environments, which is often referred to as the adoption of water-sensitive urban design or green infrastructure, as you can see on this slide here. Whole range of different ways that we can deliver sediment basin, ponds, biofiltration, wetlands, all of which are directed at removing certain parts of the contaminants that we find in the urban stormwater.